Let's do an example with the vertex formula. In particular, we'll take an example straight from the homework. The number of breeding pairs of house sparrows in a city is quadratically related to the Schumann disturbance. Schumann disturbance is calculated by taking some part of the city and counting how many pedestrians pass through it in a minute. The reason for this is that house sparrows, as their name sort of implies, they're urban creatures. So if there's no human activity, they don't do well. At the same time, it's possible that there's too much human activity and they don't do well. So their populations look kind of like this. Here is the number of breeding pairs. Here is human activity. If there's too little human activity or too much human activity, the sparrow population won't do well. Somewhere in here, there's the sweet spot where the number of breeding pairs is maximized. So let's go back. We never actually finished reading the question. So here's the formula relating the number of breeding pairs to the human disturbance. And we'll pass over A, and we'll look at B. Calculate the level of human disturbance that will lead to the maximum sparrow population. What is the maximum sparrow population? So the word vertex doesn't tend to show up in these word problems, but the maximum sparrow population occurs right here. And that is the vertex. So we are looking for the vertex, even if that word is not being used. And let me copy down this equation. And let's copy down the vertex formula. And now it's going to be plug and play. Here's A, here's B, here's C, but C doesn't appear in the vertex formula. I'm getting some kind of weird lag. I hope it's not too noticeable. negative B divided by 2 times A. And now we'll just go over to our calculator and we'll plug that in. Negative B, 15.278 divided by 2 times A. $16.75 pedestrians per hectare per minute. So this is a level of human disturbance. And we are asked for the level of human disturbance. We're also asked, let me find this. No, these are my notes. They're here somewhere. There we go. We're asked for the level of human disturbance that will maximize the sparrow population. We found that. Now we're asked what is the maximum sparrow population. So we just go to our equation and we take this x we found and we stick it in there. Y equals negative 0.471 times 16.75 squared plus 15.278 times 16.75 minus 21.338. And there's nothing very exciting about to happen. We'll go to our calculator, and this is the kind of tedious part of the problem. We will faithfully enter this into our calculator times 16.75 minus 21.338, 366.7 breeding pairs. The actual sparrow population will be higher than that. I mean, these are pairs, so each of these corresponds to 2 sparrows, and we are not counting chicks or birds that aren't breeding. But here's our answer.